So when we look at graphing sine and cosine, we're going to first start with sine values from 0 to pi. So these are values we've been kind of working with over the past 4 sections, and we're going to reference them again now. So these are standard values. You should have these memorized, if not already, very soon. In fact, it should go to 2 pi. Anyway, so 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. And these, you should have these memorized as well, the sine values and the cosine values. And ideally, you'll have them all memorized very soon. Sine, cosine, tangent, cosecant, secant, and cotangent. So, but not to overwhelm you right now. So if x is 0, sine of that's 0. If x is pi over 6, sine is 1/2. If x is pi over 4, sine is square root of 2 over 2. If x is pi over 3, sine of that is square root of 3 over 2. If x is pi over 2, sine of that is 1. If x is 2 pi over 3, sine of that's going to be square root of 3 over 2. Those we're getting in the second quadrant here, where sine is still positive. If x is 3 pi over 4, sine of that is square root of 2 over 2. If x is 5 pi over 6, sine of that is 1/2. And if x is pi, sine of that is 0. So this is what that first half of the unit circle would look like if we graphed it on an xy plane, not on a unit circle. So as x gets bigger in that direction is my point. So these are those values that correspond to up here. And then it goes down below the x-axis. This is where sine is negative in the the third and fourth quadrants. So kind of want to relate it here too. Here are these first few values related to the xy plane. So from the unit circle to an irregular xy plane, where x is the value of the angle that you found here. So x is those values. So kind of making this transition from unit circle to this xy plane. And we get this curve like so. For values of the cosine function from 0 to pi, you would have, again, 0 to pi. And let me make this bold. This should be bold. For x being 0, cosine of that's 1. X being pi over 6, cosine of that's square root of 3 over 2. X is pi over 4, cosine is square root of 2 over 2. X is pi over 3, cosine of that's 1/2. X is pi over 2, cosine of that is 0. X is 2 pi over 3, cosine of that is negative 1/2. X is 3 pi over 4, cosine of that is negative square root of 2 over 2. X is 5 pi over 6, cosine of that is negative square root of 3 over 2. And x is pi, cosine of that is negative 1. And so this, again, would be the first 2 quadrants of the unit circle. And we see this pattern and it comes back up like that. And one thing I want to point out on a sine, here's the typical period 0 to 2 pi, goes up to 1, comes down to negative 1, and goes back to 0. It repeats this process in either direction. For cosine, it starts high, goes down to negative, so starts at 1, goes to negative 1, and goes back up to 1. That's considered one period from 0 to 2 pi. So sine, I want to stress, it starts at 0 and it completes a cycle for 2 pi cycle at 0. And this is, I don't say it's arbitrary, but we're choosing from 0 to 2 pi as a standard cycle. Really, you can even say pi to 3 pi gives you all the values, but our standard period that everyone talks about is going to be 0 to 2 pi, and then unless it gets compressed by other factors you'll see soon. So note the sine is an odd function. The sine of negative x is sine of x. That means it is symmetric with respect to the origin. So this see up here, see that down there, this here, up there. Cosine is an even function, meaning cosine of negative x is cosine of x. So it's symmetric with respect to the y-axis, and it's a mirror image here. So characteristics of the sine and cosine function. The sine and cosine functions have several distinct characteristics. They are periodic functions with a period of 2 pi. The domain of each function is negative infinity to infinity, and the range is negative 1 to 1. This is for the standard, and things can shift it around. The graph of y equals sine x is symmetric about the origin because it is an odd function, and the graph of y equals cosine x is symmetric about the y-axis because it is an even function. The general form of a sinusoidal curve, this is general, so we can add other things in. So this isn't what the standard that we have. This is the general y equals a sine bx minus c plus d, and that y equals a cosine bx minus c plus d. A is what we call amplitude, and that talks about how high it's going to go. So if you get something like 2 in front, it's going to go up to 2 instead of going up to 1, or going down to -2 instead of going down to -1. B will affect the period such that the period is 2 pi divided by the absolute value of b. So if b is 1, as we've seen so far, it's just 2 pi. But if b was 2, the period will be pi. It means it's going to be, instead of something like this, it might be doing, in a much shorter distance. It changes that frequency. C affects the phase shift. D affects the vertical shift, so it'll shift it up and down. So the phase shift is what's going to shift it to the right or the left in that graph. So determine the period of the function f of x equals sine of pi over 6 x. So the period is going to be 2 pi divided by pi over 6, which would be 2 pi times 6 over pi, multiplied by the reciprocal. The pi's will divide out, and we'll get 2 times 6 is 12. So the period is 12. Okay, so this video has been a little long. I'm going to stop here, and we'll make another video starting up with determining the amplitude.